Now, OmniCenter also has this concept of service checks, and service checks are different than the polled data in that they're really kind of binary, right? So these are things that we would check for up or down. It's really technically trinary because you can have warning results within service checks as well, and warnings with service checks will generate alerts. But service checks can either fall into an active or a passive state, and this depends on whether or not OmniCenter is actively doing something about checking the state of something or whether it's waiting for another process to update it. So an active check might be like, go get a web page and validate that it comes back with the right text and a 200 OK from the web server so that it all looks good. And then you can set a timer so it does that on a regular basis every couple of minutes. It's running the same check again, validating the results. That's an active service check. A passive check is something that is going to sit on OmniCenter and wait for something else to update it. For example, interface status checks are typically updated by the polling process. So it actually is going to wait for, when we're already pulling data from that device rather than initiating a new connection to it just to check the status of the interface. It's going to wait until it's already getting all of the interface data as the result of pulling the bandwidth. And when it does that, it'll update the alert at that time. So if we go to pull the device and one of those interfaces is administratively up but operationally down, the interface status check can be changed to a critical by that process. It doesn't require OmniCenter to launch a new process to do that. Now, with the service checks, they are also subject to something called parenting and retries. So the retries are basically built based on how you've configured them to retry. So we'll look at the timers here in a little while, and you'll see there's actually an indicator where you can see if the service check has got retries pending or if it's already reached its limit of retries. So if it's still got retries pending, it's going to show up as being in a soft state. And then once it reaches that maximum number of configured retries, it'll go into a hard state. The hard state will then trigger a reachability check. So in other words, if let's say I'm looking at a web page stops responding, the first thing I'm going to do is I'm going to check a reachability check and say, is the host even up? Is it the web page is down because the host is down? And it's going to do this out of band. So it immediately will go check the host and it'll check all the parents of the host. So it'll actually crawl all the way up that tree to the parent, to the parent, to the parent, to the parent, to the parent to verify kind of where the root cause of the problem is. And the highest device in the tree that fails is the root cause of that outage. So the idea is, let's say a remote router goes down. I'm going to lose connectivity to all of the servers and switches and other devices behind that router. When that happens, OmniCenter may detect that first by looking at a service on a remote server and say, hey, the web service on that server is down, because that just happened to be the next thing that was queued up for checking at the time that the router went down. What that's going to do, though, is it's going to cause OmniCenter to walk all the way back up that tree and say, are all the intermediate devices up and this is a problem with that server? Or is there a break in that connectivity somewhere in the meantime? That's the parenting concept. And when the parent breaks, all the children alerts are automatically suppressed and consolidated into a single incident. So you get an incident that says the primary alert here is that the router went down, and the secondary problems that caused are all these other systems that are now unreachable. Now, when you configure a service check, you can set the alert after timer to control the retries and the check interval. Now, this alert after can also be set to custom, and when you do that, it's going to expose these different advanced options at the bottom here that are going to give you some additional options to set. So it's going to show you first the check interval, which is how often in minutes to run the check, and it's going to do this. This is round the clock. This is when everything is working. How often am I checking this service? It's then going to give you a failure counter, basically saying, okay, so if this fails, I need to retry this at a faster interval. So I'm going to recheck this at 1 minute interval until I reach a total number of failures. So it's when it gets to a total of 3 failures, then I know, all right, now this is now in a hard state and I can start looking up the incident logic and the reachability checks for the hosts. So just by way of illustrating that, when we're monitoring a device, every 3 minutes, we're checking the device. Whoa, that web check failed, got a page not found. That's a soft error. We're going to continue to retry that problem. So we're going to retry it twice at 1 minute intervals. That's the third retry. So those timers we just looked at, that was the maximum number of retries we had set. So as soon as that happens, we declare this a hard state. And the hard state is going to trigger us to immediately do a ping check. Now, if we do a ping check and the service is up, or the service is down, but the host is up, you're going to get a service failure, not a host outage. It's going to open an incident for that service and send out the notifications as appropriate. But let's say hypothetically, if it didn't reply to that ping check, what would happen? So it's going to time that ping check out. OmniCenter is going to check all of the parents of that device and say, who in this process is actually causing the problem. So it's going to check all the parents, and then it's going to say, okay, these guys responded, but this guy did not. Therefore, we have a parent host failure. Now, this guy is going to become the primary alarm in that incident. The other devices are going to be marked unreachable, and the alert is going to go out for the host contact of that primary alarm device so that the individual server alerts will be automatically suppressed and bundled with the incident.